going to do is we're going to just add on a little bit more, a couple more exponent properties to the ones that we've already looked at. The new ones are kind of in the second thinking cloud down here. We have what we do with zero exponents and what we do with negative exponents. Both of these are actually pretty easy, not as scary as you might think. For zero exponents, anything to the zero power other than zero is 1. 0 to the 0, just write out what I mean real quick. That's what we call undefined, sort of like dividing by 0. I'm not going to give you that anyway, just so you know there is one weird exception. X, any variable whatever, any number other than 0, anything pretty much to the 0 power is 1. So that's one super easy rule. The other new rule is with negative exponents. Here I have x to the negative a. Whenever we see negative exponents, our standard rule or convention is to rewrite them. We rewrite them as reciprocals or fractions. That negative exponent gets sent down to the denominator and becomes positive. So x to the negative a becomes 1 over x to the positive a. We'll also need to use the 3 rules that we've already talked about. Multiplying turns into addition, division turns into subtraction, multiply inside and outside exponents together to simplify some of these problems. But a lot of them are going to feel nice and easy. So starting off, first one is x to the negative 2. I just need to rewrite that. Anytime I have a negative exponent, it becomes 1 over, and in this case, x to the positive 2. So your exponent moves down to the denominator, the exponent itself becomes positive, nothing is left in the top of the fraction, so we write a 1 there to show that everything is canceled out of the top of the fraction. Next up is 12 to the 0. Anything to the 0 power other than 0 is just 1. That's it. Pretty nice, huh? Okay, the rest of these will kind of combine what we've done before with our new stuff. So this next one, I have a divided by a squared. Remember when you don't see an exponent that's like a hidden 1? I know that when I see division, I need to subtract my exponents. So I'm thinking a to the 1 minus 2. 1 minus 2 is negative 1. And yesterday we would have stopped here. However, we need to rewrite that as a fraction. Negative exponents turn into fractions. So a to the negative 1 is the same as 1 over a to the positive 1. If you wrote it like that, I'd be very happy, but kind of the reverse of what we had back here. If it's a 1 exponent, you don't have to write that exponent. So chances are if you had something multiple choice, it'd be written as 1 over a, but 1 over a to the 1 means the same thing. So this one is equally good. Let's try another one. Here I have r to the third with a negative third power on the outside. I know that inside exponents and outside exponents need to multiply together. So I'm thinking r to the 3 times negative 3. 3 times negative 3 is negative 9. Can't leave my answer like that though because I have a negative exponent. I've got to kick that down to the denominator. So r to the negative 9 is the same as 1 over r to the positive 9. This one's basically the same idea. Remember that if you have like both a number and a variable, both items need to get that 0 power. So I'm thinking 4 to the 0, x to the 3 times 0, which is also 0. We know that anytime we see a 0 power, that's a 1. So 4 to the 0 becomes 1. X to the 0 becomes 1. So 1 times 1 is just 1. You can do a lot of these problems multiple different ways. If you just recognized, hey, this whole thing is getting a 0 power, anything to the 0 power is 1, you could save yourself some work too. More than one way to get to the right answer. Next up, I have m to the 1 times m to the 1. There's kind of a hidden times dot there. We know that when we're multiplying, we add exponents together. So I'm thinking m to the negative 1 plus negative 1. Negative 1 plus negative 1 is negative 2. And then once again, negative exponents need kicked down to the denominator. So my final answer is 1 over m squared. Remember, when you kick something down to the denominator, this becomes a positive number. More of the same, n to the 5th times n to the 0. I'm going to add my exponents together. And 5 plus 0 is just 5. I ended up with a positive exponent answer there, so I don't need to do anything else. Another way you could have thought of the same problem is you might have recognized, hey, n to the 0 is just 1, so I have n to the 5 times 1, which is also just n to the 5. That would work too. However makes sense for your brain is fine with me. More multiplying stuff together. So I'm multiplying all these, so that means I'm going to add all those exponents. So I'm thinking -3 plus 4 plus 0. -3 plus 4 is 1, plus 0 is 1. So I get 2 to the 1, which would be a perfectly fine answer, or I get 2. Either way is fine. I'd be happy with this or this. And then last but not least, you can tackle this one 2 different ways. The first thing would be, okay, I know I need to multiply these exponents together. 3 times 0 gives me 0. Anything to the 0 power is just 1. That'd be one way to think about that. The other way to think about it is you think, oh, this whole thing is getting raised to the 0 power. Anything to the 0 power is just 1. So you can think about that a couple different ways as well. Hopefully now you're feeling like an Exponents rock star. Have a fantastic day.